So today's session, we are going to look at under the system design, the data design part. And we discussed last time how user interfaces are designed, what key principles that we have to think about when designing applications. So today's session, we are going to look at the next one, that is data design part, which is very important, and you have maybe some of the material you have already covered in previous, in database courses as well. So this will be a review then. Now, to start with, so this diagram shows you simple database environment where we call it a database system. So usually in databases, we store data, and data actually two types, your actual database, and also we store some data about data, which we call metadata. And when users needs to access the data stored in these electronic databases, we have to use various ways. We can use some programs to access your data. Or if you're a programmer, for example, you can write directly SQL queries to access the data. Now for that, as the interface, you have to have database management system software, which consists of a couple of things. First, you have to have software to process your queries and the programs. And the second one, you have to have software to access the data. Right. So this will give you a basic view of how database system look like, where you have electronic data and users can access through various programs. Now that we have this electronic version, but traditionally, we will store data in multiple places. In early days, before, when we had, separate databases, so the data resides with the code where the application program. So what has happened in different departments may represent same information in different manner, which lead to consistency problem. So that's why nowadays we will put up everything together. So in traditional file processing system, the data is redundant. A lot of storage will be wasted and it's inconsistent. And especially when data is incorporated with the code itself, when difficult to modify application as well. So these are some of the concerns we had. Right. Then electronic databases came in. And now if you look at database management systems, there are many ways you can interact. For example, you can now use speech as the input and output of your database interface. And most of the web application, we use the web browser as the interface. Third one, now, for example, if you go to ATM Bank has, separate interface where you can use different key combination to interact with the data you have. And then there are some interfaces for administrators, which they can use to create accounts, grant different authorizations, such as some readers are given authorization only to the read data. Some users are authorized to read and write and so on. They can also setting system parameters, and they can change in the schemas, the structure of the database, and even how they access the data. We call access paths. Right, now same thing, which is very detailed view you will see here. So in previous one, we saw a very simple interface where we had users and programs. But actually, when you set users, there could be many types of users are involved in database. For example, we have database administrator staff. Then there could be some casual users who use the database. There could be programmers. There are parametric users, which means general users who uses the system. So likewise, you can see many can access the database. But when they access in the database, they access in different way. Now, for example, database administrators, they can use SQL statements to directly access. So they might have sometimes privileged commands. Casual users in other way, they can use interactive queries. And those who program, they can use application programs. Like, for example, we can access the data using a Python program or a Java-based program. The last one, parametric users, that means very general users, they can access the data using predefined set of what we call transactions. Now, for example, if you take ATM, everything is predefined, isn't it? You go there and you put the PIN number, then they might ask you whether you want to withdraw or deposit. You know, it's well planned, compiled. We call canned transaction. Although these different users access the database in different manner, within the database management system software, we have to have couple of things. First of all, there should be compilers for these different interfaces. So, for example, database administrator staff, we have DDL compilers. Casual users, we have casual compilers. And for application programs and parametric users, we might have DML compilers and so on. And then we have to have some runtime database processor to actually access actual data stored in the database. And the system also should support concurrency, backups, recovery, subsystems should be there, right? This is just to get the overall idea of what is happening within a database management system. Okay, now that we discuss about the general database management system, we want to talk about the modeling as because we are discussing the data design part, isn't it? So when you want to data design, irrespective of what database you are going to use, we have to use various methodology to design the database. So there are three models we are going to talk about: conceptual model, logical model, and a physical model. Conceptual model means very high level idea of the database. For example, we can use ER modeling as a conceptual model to start with in a relational database management system. So the diagram that you are getting from ER modeling, we normally call ER diagram, and ER stands for entities and relationships. So what ER model does, it describes our data requirements as entities, relationships, and attributes. So which we can use then to build the logical model, and then you can implement using whatever the interested database management system. Now, for example, nowadays we talk about SQL, NoSQL databases. You might wonder whether we need the schema or conceptual data model to start with. Other answer is yes. For example, if you take MongoDB, we normally call schemaless. But the actual thing is, at later stage, when you want to improve the efficiency of the database, you have to have some schema. It might not be rigid as relational databases, but you have to have a schema. So this high-level data modeling is very important, irrespective of whether you are using a relational database model or even a NoSQL type database. Right. Now, let's take an example. So this particular example I'm taking from Navate's database management system book. So it's about the company. and they are describing company requirements. So usually we start with the similar description when you are going to create an ER model, right? So when you want to represent some data elements in ER model, you first need some requirements. So here we have data requirements as some statements. So let's try to understand. Now the text reads as it's about the company, and they say company, they organize into departments, right? And then they talk about, okay, what attribute which describe the department. For example, they say department, you have a department name, department number, and there will be an employee who manage in the department. And again, we are keeping track of a start date of the department manager. And the department also have several locations. So you see, it describes about the company and then about the department. Okay, next statement. Each department controls a number of projects. Each project has a unique name, unique number, and located in a single location. So now it says, okay, we have a company, we have a set of departments. Now it says, okay, department, they operate or they work on a number of projects, and they describe the attributes. Okay, description goes on. We store each employee's name, social security number, address, salary, sex, and birth date. Each employee works for one department but may work on several projects. We keep track of number of hours per work that an employee currently works on each project. We also keep track of the direct supervisor for each employee. Now you see, our company, now we have discussed about the department, we discuss about the projects. Okay, now we describe about the employee and what attributes we are going to keep. Apart from that, we will describe some relationship as well. Now we say, okay, employee works for one department and then they may work for several projects. You see, we talk about the relationship. Last one, each employee may have a dependent. Okay. For each dependent, we take their name, sex, birth date, and relationship of the employee. So the last one is talk about the dependent, like employee, whether they are having their details, right, as dependent. It could be parents, it could be your partner, right, or family. So that's the dependent. Okay. Now, I'm not going to talk about ER mapping part or how to draw the diagram. I hope you already know that, and I don't want to spend time on that. But let me show you key point I'm actually looking for, especially when you're developing a ER diagram. Now you see the notations are very important, and from book to book, from company to company, sometimes there are slight differences in notations. So this diagram, for example, I'm taking from Namate's book, which I think the standard representation. So now we discussed earlier that we have departments, and the department has a department name, number, and department operates in multiple locations. So you see here, department as a rectangle block. It's represent the entity type. Similarly, if they have a couple of projects, the projects also have attributes name, number, and location. Then we have employees, and employees are described using social security number, birth date, name, sex, address, and salary. And employees has dependents. Dependent, we have name, sex, date of birth, and relationship. Okay, so now you can see there are three regular entity types. What do you mean by regular entity types? To become a regular entity type, you should be able to identify one attribute as a key attribute. Key attribute means it should be a unique attribute. It's not, don't confuse the primary key. It's not the primary key. Key attribute means it's unique to that entity. So for example, employee, we can identify social security number. So that is a key attribute. Department, actually there are two key attributes. Department name is unique. Department number is also unique. So that's why you have underlined, which indicates that they are key attribute. Similarly, project also, project name and number, they are unique. So we can say they are key attributes. Okay, so that's the first thing that you need to understand. But if you take dependence of dependent name, it's not a key attribute. The reason is this is known as a partial key. So whenever you have partial key, your entity become a weak entity. Why we say weak entity? Without employee instance, without this relationship, there's no existence for this particular entity. So therefore, we are identify this as an identifying relationship. So the key attribute actually coming from this side and which combines with the name here. So this becomes weak entity type. Right, now that's the first one. You identify each of the entities, then you identify key attributes, then identify relationships. Now employees works for department, so works for is a relation. And some employees works as managers. So managers is another relation. Employees works on a couple of projects. So works on is another relation. And department controls projects. So controls is another one. And here we have recursive relationship, which means for employees, some employees supervise the others. So we have a supervisor-supervisee relation. Right, now that we have identified relations, the next time is the cardinality. Cardinality means each of these relations, we have to have, right, the type of relationship we should understand. So there are three relationship types we discuss, one-to-one relation. Now, for example, if you take an employee can manage a department. And if you take a department can have a one manager. So this is unique, one-to-one relationship. One employee works for one department. Department can have one manager. So it's one-to-one. Then we have one-to-many relations. We have employee works for department. So when you take a particular employee, he works only for one department. But if you take one department, there could be many employees. So this is to say one-to-many or many-to-one relation. Third one, if you take one instance, employee, they works on number of projects. And if you take a single project, there could be multiple employees works on. So whenever we have a situation, we will say we have a many-to-many relation. We have many-to-many relation. Now, when I say many-to-many relation, you see, you can see in the both side, its relationship is many. So you need to understand that as well. So now we identify entity types, its attributes, right? Then the relations, then cardinality, whether it's one-to-one, one-to-many, or many-to-many. The next one is there are other type of attributes as well. When you have multiple location, we normally use double ovals, which indicates that this is a multiple value. And when you have a derived attributes, that means based on whatever the existing, if you can come up with a new set of attribute, we call number of employees, for example, that can have effect aggregate function. Right. Now, entities, as we have already seen, they are some objects and it represents the database. So when you say employee, a particular name, John Smith, or research department, or product X, they are entities. Then we have properties, which describe the entity we call attributes. So when you say employee name, It's an attribute. So when you take, for example, particular row, so you will have each of these entities, you have to have value. So for example, if you have name, you have to have a value for that, social security number, another value, address, another value, and so on. Further, you will also note that when you take an attribute, you will have a set of unique values. You will use integers, strings, substring, enumerator types, so they are associated with this. Next, there are two types of attributes we can identify. Simple attributes, which means you will have a single value. Let's say you will get gender, male, single value. Or you can have composite attribute. For example, if you take address, there are various parts of the address number, house number, street, city, state, country, and so on. Same goes with your name as well, first name, middle name, last name. There are many ways that you can, decomposed. So after that, you can actually use it. Then we will also have multi-value. Remember, we have seen earlier locations. Then we have derived attributes like getting age from date of birth, which we call derived. Right? So these are like type of attributes we can talk about it. Right. So some notations we have discussed earlier, I think you are. So attribute, usually we have oval shape with a line which connects to that entity type. Then if it is a key attribute, you should underline. If it is multi-valued attribute, you have double lines. If your data item has multiple parts, we can have it as a composite attribute. And then there could be some values are derived from other attributes. So here is the notation that we have to use. Now the second one is the participation. So I already discussed about one-to-many relation. So here we will take one record which connect with the n records with E2. But if you get one instance from E2, it will connect only for one. Right. So this is the kind of a notation that we would like to discuss. Right. Okay. So exercise I'm going to skip because we have a separate group work to work on. So let's move on. Now, when we talk about the relations or relationships, it could be two or more. Right now, in the example, we see only two, right? Isn't it? If you go back to my original one, right, you have two. Two entities are participating for this relation. Two entities are participating for this. Actually, you could use another one, right? Depending on the requirement, you can have another one to, get used to this. Right. Now that we got the basics done, right, we can actually use to complete reference from searching related information. So what we can do is we can construct this with an example. Right, now weak entity types. Now entities that does not have a key attribute. Remember in our example, we had a name as the partial key. So that means you don't have a key attribute to identify without the help of identifying relation. So that's why in our case, dependent has identifying relationship, right? We have to have that. And then there could be different relationship types can be existing. Now, managers and works for in same department, isn't it? Now here, for example, we have two entities, but you can have any number of relations, right, between the two. Right. Okay. Now that we got the idea about this, right? In weak entity type, as I told you, there's no unique key. So for example, here dependent, we have a dash key, which indicates that you cannot take this as a key attribute. So you have to get the social security from this side to make it happen. Right. Now, the relations. Remember, we discussed that when we want to represent the entity types, and then we put up the relations between the entity types, then we have to say whether the relation is one-to-one, one-to-many, or many-to-many. This is actually representation or the participation of the entities in the relation. So when you say one-to-one, what it means, if you take exactly one, it will connect with one record in the other entity. When you say one-to-many, in one side, when you take one record, connect with many records. But if you take one from the other side, then it will exactly connect into the one record. So we will have one-to-many. Finally, we can talk about many-to-many. So that means if you take one record from one side, it will connect to the many records from the other side. Same goes with the other way around as well. Now think about this. Let's say we have the data table or entity called Vice Chancellor and another entity called University. What kind of a cardinality ratio you can observe? Is it one-to-one, one-to-many, or many-to-many? Vice Chancellor and University. Yes? So I got answer from Ishan and Hansaka. Good. Yes, it should be one-to-one, right? Take a vice chancellor can work only for one university, and a university can have only one vice chancellor. So assuming that is the relationship, it is one-to-one. Now, what about the lecturer and the university? What kind of a relationship we can find? It should be one-to-many, right? If you take one particular lecturer can works for a university, but university can have many lecturers. So it's one-to-many, right? Then when you take lecturers and students, it'll be many-to-many. We take one student can learn from many lecturers, lecturer can teach for many students. So you have many-to-many relation. The second one is minimum cardinality. We will say whether the relation is a total or partial. I will go back here. Now explain what it means. Now, for example, let's say we have employee and department relation works for. It's one-to-many relation. So department can have many employees, but employee can work for one department. Perfect. The second one, if you take all the records in employee entity, are they participating in the works for? Yes, because every employee should work for a department. So therefore, you have a double line here. Similarly, here as in department also you have to have employees, so the double line. So double line is to say that it's total participation. That means all the instances will participate for this relation. Okay, now look at this relation, managers. It's one-to-one. That means employee can works for the department as a manager. Department can have one manager. So that's why it's one-to-one. Now total participation. All the department, you can have a employee who manages the department. So that's why double line here. All the department. But here you can see a single line. It say that there are some employees who will not be working as managers. Right. Now that we have understood this, let's go back to the next part. Right. Now, when you are representing these relations, remember to use one-to-one, one-to-many, or many-to-many by placing in the link on number on the link. And the second one is partial participation constraint, whether all the instances are participating or not can be shown by using double lining the link. So when you say double line, it means it will participate all the entities, right? Okay. Now, so far what we discussed, we had only two, right? Entities are participating, but actually there could be many. If you have three, then we call ternary. If you have n, we call n-ary, right? So remember, very important. So although we have seen all the relations as two, because two entities are participating. But of course, you can have another one which connects the relation, which becomes ternary relationship. Right. Another idea that I would like to discuss, sometimes you have a recursive relationship. Recursive means you are referring the same object. So for example, here, if you take this example, this is one such example. So in recursive relationship, you will see that normally you have two sides are named because it connects in the same. So supervisor can have many supervisees. Supervisee can be supervised by one person. I think now it should be familiar to you. Right. Just to summarize what we have discussed about the ER diagrams. Now, ER diagram represents the high-level overview of the database system, which we can say that it represents the schemas. When you are naming, remember to use regular names and uppercase letters for entities and relationship, which is a good practice. Again, this is proposed in the authors of the textbook. Then attribute name should be capitalized. Role names should be in lowercase. And then you use each of these participation. Okay, is it one-to-one, one-to-many, or many-to-one? Then partial participation comes from, right? That means you can either use a single quote, which indicates that it's a partial. You can use double lines, which indicates a total, right? So when you're given a description like this, sometimes you might not get all the required information. So whenever you think something is missing, you should make some assumptions to make it complete. Right. Okay, so now that we have discussed about the ER diagram and how to draw ER diagram, The next thing I would like to show you different representation. Different diagrams use various different notations. Let me show you some. First one, this is how entity relationship diagram look like here. Very simple. You have a sales rep, customer, order line, product, and then you will also have relations in between. And they are numbered properly as well. Right. Now, when you're connecting, so for our original previous case and this one, you see the numbers are put in the two sides. But if you're using crow's foot notation, it's like this. So this is the entity type, and then line indicates the relation, and it ends in a special way. And you have a special meaning as well. For example, if you take the first symbol, it's about one and only one. Second one or many. So we have one to many, then 0 or 1 or many. So that means the minimum value could be 0, but then, yeah, you can have many. Then when you have 0 or 1, simply it goes with 0 and 1. So likewise, right? Different notations you might see, and this is what it needs to be. So you can see some relations. Customer places order. Order includes item record. Employee has spouse. Employee assisted to project. So these are some instances which can be used. Now, although ER diagram is a good one, there are some issues. Now, for example, especially with these object-oriented programming languages, right? We want to use some advanced hierarchy, generalization, specialization, class information. So then this is not the best one to use. So therefore, since this general representation will not support specialization and generalization, we have to make use of them. Okay, so the next one, I'm going to talk about the equivalent UML modeling diagram as well. Because when you're going data design, sometimes you can focus on traditional structured analysis, or else you can go for object-oriented principles. So UML is another language that we can actually use represent. And what we are going to learn here is UML class diagrams, which is very similar to ER or enhanced version of a ER diagram. And not only that, UML class diagram supports other types of what we call behavioral diagrams, sequence diagrams, state diagrams, activity diagram. So likewise, you can have various types of diagrams to support the modeling. Right. Now, the difference between the terms that we will use. In UML, we use class, but in database perspective, it's entity type. In UML, we talk about the objects we are creating. ER, we have entities. UML, we have associations. In ER, we have relationship type. Right? And then binary association type, link attribute, relationship attributes, multiplicities, relationship constraints, reflexive association, recursive relationship. So these are some terminology you should be familiar with. Now that we have the ER diagram, next thing is let's look at how it looks when you put in the UML diagram. If you carefully look at it, let's say employee, all the simple attributes are included, isn't it? All the simple attributes are included. And you can even think about which attribute can be used as a key attribute. Similarly, we can do the same for dependence. So in dependence, you will see we are going to keep track of their gender, birth date, and relationship. And this is what you will see here. Right, now, when you compare this with the ER diagram earlier, you see a couple of things. Because this is class diagram. Classes consist of three parts. Employee, in this particular case, the name of the entity, in this case, class. And then you have a set of attributes, and then you have a set of method, which we don't have in ER diagrams. So within this example, you will see there are several attributes like name, social security number, birth date, and so on. And then if you look at the dependent, you see you can have male, female, birth date, and then the relationship. Right, now let's look at another example. Now, if you remember employee and the department, we had two relations. One works for. So when you take an employee, he definitely works for a department. So we have min-max notation here. We will use 1 and 1. Similarly, if you take a department, what is the minimum value you have to have according to this notation? We have to say 4 times into asterisk, right? And the second one is the managers. You can see here 1-to-1, which means department can have employees and so on, 1-to-1, the minimum and maximum value of that link. So let's look at the works on relation. Right, so these are the basic notations that I would like you to familiar with. Given a problem, you should be able to identify equivalent relational database schema, or if you are given a Unicode, the same code you can slightly put in a separate form. Right. Now that we discussed the basics, the next thing we are going to focus on data modeling aspect. When I say modeling, right, next we are going to discuss about logical model. Now conceptual model we have seen in so we have ER diagram and we have UML diagram. So both represent the conceptual view. So let's look at the relations. We have to map them, right? So first start with the entity types, then weak entity types. Then we have mapping for different relations, one-to-one, one-to-many, and many-to-many, and mapping on cultivated attributes, and mapping of in-array relationship types. So in-array means now usually if you have two, we normally use two So we will have binary relationship. If you have 3, we have ternary relationship. So depending on the requirement, you have to select that. Right. Now, given this one, and this is a conceptual model. The next one is you should convert it back to a relational model. That means your entities should be put into what we call relations. So you can see we have employee, department, project, dependent. So all these are there. So the first step is for each regular entity type, you should create So for example, here we will get employee, and employee we put it as a separate relation. Similarly, department is also another relation. Project, another relation. Dependent, another relation. Right. Okay. The next one is attributes. So when you have putting relations, you use all the simple attributes. Now, what are the simple attributes here? We have birth date, social security number, first name, middle initial, last name, sex, address, and salary. So all these should appear here. And you should underline the primary key. It's a social security number. So same thing can be done for department. We can have name, number, and location. Project, we can have name, number, and location. Right. Now, once you have finished all the entities, that means we can use employee, we can use department. Remember, department, we have 2 key attributes earlier. Select one as the primary key. Now here, we have 2 possibilities, right? And you will select only one as the primary key. Similar project also you can put. Right, okay. Now that we have used this to represent all the regulated types and their attributes, next, we have to convert or we have to map the type of relationships, one-to-one, one-to-many, or many-to-many. So let's look at how we are going to do this. Now let's take an example. Okay, so maybe I will type it here. It'll be more clear now from here. So we have employee and the department. Right now, what I told you is we can have employee. Let me change the color. We have employee. And we have list all the regular attributes. What are all the regular attributes? So we can say social security number, that is our primary key. First name, middle initial, last name, sex, address, salary. Right? Even you can have birth date. Now, the next one is the department. So we have department. We have department name, department number, right? Locations are not included because it's not a simple attribute. So this is what we can have. Now, my question is, we have one-to-many relation, right? So when you have one-to-many relation, how do you make the connection? Yes, how do you make the connection? Right. Now let's focus on the works for relation. Can you tell me how can I connect these two relation to represent work for relationship? Any ideas? So let me first draw the primary keys. So social security number is a primary key. Let's take department number. This is a primary key. Okay, now that we have defined primary keys, how do you connect these two? My question is, how do you connect these two? These are distinct. Now, how do you make this relation? Works for relation. So how do you combine the two? Which attribute I had to use? Where? Okay, Ishan gave a suggestion. I think good. It's really good that you came up with the suggestion. Okay, you mentioned about the foreign key. So when you talk about the foreign key, we can do two things, right? First of all, we can either put social security number here, or we can put department number here. So let me put as this is my choice 1. Let me put this is my choice number 2. Okay, that's good. Now, which side I should make the connection? Should I use social security number in the department side, or should I use department number in the employee side? 1 or 2. In foreign key approach, we can have two. We can create a foreign key two ways. One method is we will get the social security number we put up as a part of department, or we can take department number and we put it as a part of employee. Now my next question is, which one is best and why? Can you tell me which one is more correct? Okay, Now let's think about adding social security number in the department, which creates a lot of problem because department can have many employees, which is problematic. So therefore, the best solution for this case is putting department number in the employee side. So in my case, the best way would be instead of this, so make sure that you switch off your mics when you talk, right? So what we could do is we can, instead of this, we can put department number. We can include the employee side. So that's how we make the connection. Okay, that's great. The next one. Now we have another relation between employee and the department, that is managers. That means some employees works as managers. So how do you make that connection? Which strategy you are going to use? Is it, are you going to use social security number in the department side, or are you going to put department number in the employee side? So earlier we discussed about the works for relationship. Now we are going to discuss about the managers. How do you make the relation? Yes. Now in this managers one, it's a one-to-one relationship. When you have one-to-one relationship, we should go with total participation side. That means the department. Why is that? Not all the employees works as managers. Therefore, when you talk about this relation, it should come to the department side, right? So that's how we will create. So there are some rules. So let's discuss these rules. Then it will be more clearer than how do you convert these relations, right, into transformation. Okay, so here are the steps. First of all, mapping regulatory types. We will create relations for each regulatory type and put up all the simple attributes and use one as a key attribute and make it a primary key. We have already did that. Then if it is a weak entity type, again, like in earlier, you create a relation, include all the simple attributes and take the identifying attribute and combine with the partial key to create the primary key. Right, now the mapping of one-to-one relationship. Foreign key approach is the common one. So that means one of the foreign key, we include the foreign key as a primary key of another relation. And you should select the total participation. If both participation are total, then you can join. Otherwise, you can have primary keys of two relations. You can use as cross-referencing. So you can create a separate relation for that. If you have one-to-many relationship, then also first one, if you go to foreign key approach, select the end site. So you select the primary key in the end side and the create a relation. Or else you can separate them to create a alternative approach. Many-to-many relationships. Okay, we cannot accommodate man-to-man relationship, so we separate out. So we have to create a separate entity, or in this case, relation, to represent many-to-many relationship. Right. So those things we have now discussed. So in our example, so these are regular entity types. These are one-to-one relations, one-to-many relations, and many-to-many relations. Right. Now let's do a small exercise. I want you to give me the mapping of department and project by going through this one. Can you tell me how do you represent the schema for department and project? What attributes are there for department? What attributes are there for project? Let's start. So now what we have to do is we have to think about the department and project. So like in earlier, we can have department and include all the simple attributes like department name, department number. Multi-valued attribute we are not going to consider, right? That's about the department. So project, what do we have? We have project name, project number, and location. Okay, now the question is, right, how do you make the foreign key approach? Can one of you tell me, how can I combine the foreign key approach? For controls, for example? Yes, any ideas? How do you make the connection? So one way is let's define what the primary keys are. So let's assume that, okay, we'll assume that, okay, department number and project number, they are the primary keys. Now, can you tell me, how do you make this, how do you map these one-to-many controls, one-to-many relationships, controls relationship? Yes? Yeah, so we have to put department number in the project side, isn't it? It's a one-to-many. So when you take many to many, I told you, you have to create a separate relation. It's best always to create a separate relation for that. So what you can see is this is the final answer. So I'm not going to discuss in detail, but you can have a look and how this can be put into this form. But definitely we'll have some interactive session where we will discuss in detail. I will give you some exam exercises for you to work on. Okay, So before we continue, let's take the attendance. Let me try to use the new system. Give me a couple of seconds to set up. Okay, so let's mark the attendance, and then I will continue my discussion. Okay, so let's continue our discussion. So far what we have discussed is how to use entity relation diagrams, EI diagrams, and also I told you that is a logical model of a database system. And then what you have just done is the conceptual model we have done, and this is the logical model. The next will be the physical model, which you are going to use some database system to create the table, identify data types, and also creating all these constraints. Right. Let's move on. Now we discussed the mapping one. One thing I want to discuss is how do you map multi-value attribute. Now multi-value attributes means, now I told you, like when you transform, you should think only the simple attributes. But sometimes when you have multi-value attribute, like for example, in this case, the location, that means the department can have multiple locations. So when you have a department has a multiple locations, what you should do is you should create a new relation for that multi-value attribute. Then you should get the primary key of that relation as well as the attribute. Combining the two, you should create a primary key for that. So for example, in our case, if I go back to these locations, so what you should be doing that, you create a new relation called department location, and then you include the department number, that is the primary key of the department and department location. Combining those two, you create a primary key for the department locations. Next one. When you have more than binary relationships, how do you handle such a situation? Now, when you have binary situation, we discuss how we are going to do that. But when you have more than two, then how do you handle such a situation? Now, here is an example. So we have a supply relation, and there are three entities are participating, and here are the primary keys. Now, when you have more than binary relationship, you have to create a separate relation for the relationship. So let's create supply. And then include all the primary keys of the participating entities. So we can have supply name, we can have project name, we can have partner, and whatever the simple attributes. So this will create the relation for this. And by combining all the primary keys which are participating in this relation, can form the primary key for that relation. So this is how you should transform when you have more than two, entity types. Okay, just to summarize what we discussed with ER model and relational model. ER means high-level conceptual model, and the ER model is our logical model. So entity types becomes entity relations. Relation types became foreign keys. Many relation types create a new relation and two foreign keys. When you have n-array relationship type, create a relationship with n foreign keys. Simple attributes becomes attributes. Composite attribute becomes simple component of attributes. Multivariate attributes create a new relation and a foreign key. Okay, value set means what values are supported for ER model. For example, let's say gender, we have two values, so which we call domain. And ER model, we usually talk about key attributes, and you can have any number of key attributes. Any unique attribute, we can define a key attribute, but relation model, we will take one of them as the primary key. Right. Now let's talk about the approaches for designing relational databases. So under that, we start with the conceptual model, and then conceptual model, we make it to relations. That's the usual practice. But sometimes we might not directly going into this process. but we try to understand what are the good relations, or we can directly try to create these relations or the tables. So that's what we are going to discuss under this part. Especially we are aiming at normalization, definitely. That means how do you normalize your relations? So when you talk about informally about the good design, we can talk about the meaning of the attributes we call semantics of the attributes. And we can talk about reducing redundancy in the tuples, reducing the null values. Sometimes some values are missing, we call null values. And also we should not allow to generate some false tuples. That means not real tuples. Especially this happens when you're joining two tables. That might create some tuples which are not already existing. So you have to carefully design those. Right. But when you look at the formal concepts or formally mathematical concept, there are some guidelines developed for designing good relations. These are known as normal forms. And general in practice, we should at least have our relations up to third normal form. So there are first normal form, second normal form, third normal form, Boy's code normal form, fourth normal form, fifth normal form, and so on. But at least in Indian standard, at least you should adhere up to third normal form. So let's see what all these normal forms are and what is the focus and how you make good relations by following normalization. Right. Now, what the concept that you should be familiar with when you're going to talk about this formal normalization is the functional dependency. Now, functional dependency means when you have a set of values in an attribute, and when you can find using that set to another set in another attribute, we can say we can functionally determine the other value. So that means if you have, like, let's say X and Y, two attributes, for every value that you have same values of X, if you are getting the same value for Y, we can say that, okay, if Y functionally determined by X, that simply it is, right? So mathematically, we will say X, we can say X can be used to functionally determine Y for all the instances. Now let's try to understand this idea. Now, when you have a social security number, it's like ID number in our case. For a unique ID number, you will have a unique name. So we can say, in other words, using your national ID card number, we can determine a person name. Another relation. When you look at a project number, using a project number, you can always determine the project name and project location. So we can say using project number, we can functionally determine project name and project location. Another one, when you have employee and the project number, you can use in these two, we can determine how employees works for a project, how many hours a particular employee works on the project. So that means for unique values of social security number and project number, we can determine the number of hours. Right. So now that we got the basic understanding, let's start discussing the normal forms. Now, first normal form is very simple. It says it does not allow any composite attributes. It does not allow any multi-valued attribute or nested relations. And the values should be atomic. Now, for example, if we take our department relation, we had a department name, department number, department manager, department location. And our department location is multi-value, which means, in other words, we may write like this. But first normal form, what it says is this is not allowed. Multi-valued attributes are not allowed. So that means you cannot have a relation where department number is the primary key, but you can have multiple values. This is not allowed in first normal form. To allow this, what we need to have is we have to have atomic value. So that means we have to make it to 3 tuples from this one. So what happens? We have to have research 5 this. We need to repeat the 3 times. And each value, you have a atomic value separately. To make it a key attribute, now we have to combine both department number and department location. So using these two, we can uniquely identify each of the records. Now, if you look at this relation now, it is now in first normal form. Another example. Now look at this example. We have employee project. We have social security number, employee name, project, project number, number of hours a particular employee works in. So we can, when you populate, it might look like this. But the problem here is, you see, the values are not atomic. So best way would be you separate these. So you divide this so that you break this. So social security number, employee name, you take it separately. And we are going to give a new relation. And with these two, number of hours a particular person works, we make it separate. So we will take social security number, project number, and number of hours. So these two will be the primary key, which simplifies this problem. Okay, so now first normal form is easier. We talk about atomic values, no more multi-valued attributes, and so on. Second normal form actually used concept of functional dependency that we have discussed. Now, what the second normal form says that, yes, when you take non-prime attribute, non-prime means the attributes are not part of your primary key, should fully depend on the primary key. Right. So, for example, if you use social security number and project number, using these two, you can determine number of hours is fully functional depend on. But if you use something like the social security number, project number, using that, if you determine employee name, this is not fully functional dependent, because even if you remove project number, still you can determine employee number. So in other words, we can say if every non-prime attribute A is fully functional depend on the primary key. So we can divide the relations to make it second normal form normalization. Okay, let me show you an example. Now let's look at this first one. So here we have employee project relation. In employee project relation, we have a couple of attributes: social security number, project number, number of hours, employee name, project location. Right? These are the values we have. Now functional dependency means, so using this primary key, both social security number, project number, we can determine number of hours a particular person works for the project. Second one, using social security number, you can determine employee name, right? Then using project number, you can determine project name and project location. So you can see here, if you take non-prime attributes, the attributes are not part of the primary key. Number of hours fully depend on the primary key. This is okay. But if you look at this one, this is only part of the primary key, which is violating. And this one also partial of primary key. This is also violating. So because of this reason, now we can conclude that these two are not in second normal form. Therefore, we can break this. How do you break? We take these three into one. Then social security number and name, we take another relation. Project number, project name, project location, we take another relation. So what happens? Initially, we had a single relation. Now break it to three other relations. Right. Now let's move on. Next, look at the third normal form. Our final normal form, we talk about what we call transitive functional dependency. Transitive means if we can define some functional dependency like from X, we can determine Y. But if you can find a form such a way that X can functionally determine Z and Z can functionally determine Y, this is known as transitive functional dependency. So you can see social security number, department manager, social security, transitive function dependence, because from social security number, we can get the department number. From department number, we can get department social security number. But if it takes social security number and employee name, this is not transitive, where you cannot find anything in between. Right. Now let's move on. So if we can find a relation which is transitive, that means let's look at this example. We have employee department relation. So in employee relation department, maybe I will zoom out, otherwise. Right now, I hope it's more clearer. Right, here is a relation we have given, and here are the functional dependencies. Now you can see this is about employees and the department. We have employee name, social security number, birth date, address, department number, department name, department manager, social security number. Now you can see this is the primary key. And with primary key, you can access each of these directly related. But if you look at department number related to department name and department manager social security number. So if you look carefully, there's a transitive dependency. It is because we start from here, we go to department number, and from department number, we can go here. So because of this reason, we can have a transitive dependency. To break the transitive dependency, we have to separate out. So we have to separate up to this point as one relation, the remaining as another relation. So now what happens? Here we will actually have everything about the employee name. So this solves the problem. And this one, department number, you can directly access department name and department manager social security number. Sorry. Let's take another example. Right. So in the next example, let me show you what we are going to discuss. So in this particular example, we have this relation, right? So we have, this is the primary key, property ID, and using that you can function by everything else. And you can see using these two, you can function determine the other one as well, because this is a candidate key there. So this one is another function dependency. This is another function dependency. So now let's first break, right? So we'll first remove this one. So what happens now? Country name and tax rate is actually separated. Then the remaining ones are there. But then again, there's a transitive dependency comes here. So we have to separate that one so that the remaining is consistent. So what has happened here, right? To break functional dependencies and transitive dependencies, we can separate the relation. And then finally, everything will be in third normal form. Okay, so now let's look at we have normal form. Now we discuss all the three normal forms related to the normalization.